My name is Florian Carle. I'm the managing director of the Yale Quantum Institute in New Haven, Connecticut in the US. This is a research center and an institute that bring people from different departments at Yale to build quantum technology.
Cool. And so do you think this is one of the biggest center for quantum research in the US, at least in terms of having so many departments joined together?
So the Yale Quantum Institute has been one of the first institute. We celebrated a 10-year anniversary last fall, and there's been really an increase of the amount of researchers coming in. We started with like nine faculty members, and we are currently at 30 research groups. So it's one of the biggest in the US. There's a lot of collaboration between all departments and with many research centers, national labs in the US and abroad.
And you told me that here there were already two breakthroughs. One of the first computers with the 2 qubits that you told me, and then the other one that you told me
was the real-time quantum error correction.
That's nice.
Yeah, so the institute has been the ground for a lot of breakthrough in quantum technology. In 2009, we ran the first 2-qubit algorithm into a superconductive device, and so that was one of the proof of concept of the possibility of using this type of technology, superconductive qubits, for quantum calculation and computation. And ever since, all of the elements that are needed to work on these chips were invented here. We have the Josephson junctions, some quantum buses, all of the elements that are helpful for this machine. And so the last 10 to 15 years were more focused on algorithm and how to improve these qubits, where the last 20 years were more on like building the technology and the hardware, for example. And so recently there was a lot of breakthroughs here on real-time quantum error correction. So not only we are trying to make the perfect qubits, the one that doesn't have errors, and if they do, find ways to correct them on the fly.
Which didn't take that much. That's also what you said. That's really depending what is the time scale we are looking at. But even it's like 5-10 years is quite fast development, right? Mm-hmm.
So I think one of the brilliant idea that the researcher here got is that if we can take advantage of all of the circuit boards that were invented, going from like the mainframe machines from IBM in 1950s to today's like super small devices for computers, for watch, for phones. It took us a very long time to do this jump from like a room-wide machine to something we can wear in our pockets or on our wrist. And so by reusing this technology of semiconductor and like all of this manufacturing principle, they were able to really speed up the process of because we just had to adapt how to build circuit boards, and they've used this technology as the ground to build superconductive qubits, using basically making like an artificial atom using all of this technology on circuit boards.
Okay, so when do you expect cryptography will be broken then?
That's a good question. So I think the answer for all of that is like, and it's been in 3 years for the last 10 years. So that's a challenge. I think cryptography is going to be a very important thing to solve for quantum computing and quantum technology, because this is one of the black points of all this technology, because so far all of the application of quantum technology, may it be like quantum materials to improve battery life or develop to new drugs, or something to have computation more powerful. All of these seems to be like very positive for the general public, and breaking cryptography is one of the like problematic one. Thank you. The negative one, indeed. And so I think if we focus our attention like solving this, we might remove one of the negative points and have only the benefits of the technology. I'm hoping that with the acceleration in quantum technology we've seen in the last few years, with breakthroughs from IBM, Google's, almost reaching the point where they can perform calculation that a classical computer can't anymore, or like it will take like hundreds of years. I think we might getting close, but it's hard to tell if it's going to be like 3, 5, 10, 20. But I suspect in a lifetime we should be able to see it.
And do you know anyone here at Yale, I mean, you don't need to mention the name, but someone that is working on it? I mean, the primary research is trying to break, it's really not just breaking encryption, but it's like this very mathematical, difficult task that the quantum computers could do.
So we have a lot of researchers in the computer science department working on a quantum OS, and so basically they're trying to develop like operating system that will run onto these machines. I don't know for a fact that they're working like purely to break encryption, but there's a lot of efforts to try to be ready on the software side and on the computer science side once the machines come online. And so having this effort is really important because it's easier to have the person who wants to code or develop algorithm on this new machine if you can talk to them while you're building the technology. And so I think this is why these collaborations are very vital to bring these people together before the technology is here. And I suspect it's something that's going to be also helpful for encryption by testing things slowly instead of, as we were talking about earlier on, the is it going to work? Can we break the encryption, or like, is this encryption will hold new machines coming online? And so if we can, the earlier I think we can test this theory of this encryption, we should have a better chance of either going into a post-quantum encryption system or making sure that sensitive information can be secure. I think it's very important for the general public to be aware of encryption and the need for privacy or security in communication. We've been doing a lot of courses with the School for Global Affairs that try to showcase in a hour-long class how to do quantum encryption with the BB84 protocol to try to like start the conversation around. Of course, it's a very complicated topics, but I think it's a matter, like every public policy, is that if the public is informed and if they understand the needs that they have for encryption, it might force the governments to react, or it might force companies to switch to post-quantum encryption. And so by having big companies like Apple trying to switch their iMessage to post-quantum encryption or Signal that we mentioned earlier, that might be something that will bring to the forefront of the mind of the public, the consciousness of the public, to the importance of encryption and for privacy.
Yeah, no, people are really taking action for that. It's just a question of how long it will take and how soon this threat will be here. By working here, you probably meet also philosophers, artists, we said. I wonder, probably the question of the ethics of quantum has been around in these rooms.
Absolutely, yes.
And so I wonder, what is your take on it? I mean, not your opinion, what you heard, what is circulating around.
So we bring a lot of people from outside the field. One big chunk of programming for the Institute is to make quantum technology more accessible to all. My hope is to have new generation of younger students that will consider STEM and hopefully quantum computing and quantum information as the major. But we bring a lot of high schoolers, we bring a lot of general public, we have an artist in residence program, and a lot of people are very interested in quantum. I think there's this disconnect between the interest of the public wanting to know more about quantum, but also the fear of quantum mechanics being so hard. And so like this disconnect. But by trying to have these programs mixing art and science or humanities and science or talking about ethics and quantum computing, we capture an audience that has a lot of opinions on this technology. And so we've hosted a handful of meetings with the Jackson School for Business up the hill. With Southern University, we had an event with the RC Vest.
Specifically on the ethics, because of course around culture and education there can be a lot that can be done. But on the ethics, I don't know, maybe you heard a talk or maybe you have, I got the equality, right, that should be available to everyone. But there is anything else? I mean, it's also
so I think there's a lot of, so when we have discussion around ethics, the researchers here are very interested in these problems because we had sort of this conversation before in the 1940s where with the atomic bombs and like the effect of studying quantum mechanics and the impact on like developing weapons. And so I think it's very present to in people's mind of like, we are building technology, but what are the effects of that technology on the general public, and what can we do with this? And so we have a lot of researchers that went to DC, Washington, DC, to talk with politicians and to talk with policymakers to help them understand quantum mechanics, to help them work new policies with this. And so I think the question we have about ethics is like, how can we make these devices accessible to all, and how can we put in place some guardrail to make sure that the technology we use is either like easily accessible to all, but also that we can find ways to not have the thing that happened with AI, where only a handful of companies have the tech on it, and so that's one of the important part of the institute and the researcher here is like, we're here to produce knowledge, to help sharing the information, and so I think that ethical concept is going through with all the publication and all the development of technology here.
And do you see these efforts also playing out in an international dimension, so that your scientists try to work around policy and ethics internationally? I ask, you're also European, right?
So so it's hard to tell because each government is like putting their own guideline and own policies, but the institute is highly international. I'm French. The director is Americans. We had some researchers who are French, Indian. We have a lot of Chinese, Brazilian. So it's a really interesting community, and so once we train these researchers, may they be grad students or postdocs, when they come back to their country to like become either like heads of industries or head of like their own research center, I think this ethics conversation that we had in the past in the institute will like hopefully linger with them, and they keep this idea, and so it might affect them, but there's not really a strong effort to like talk to other people.
Yeah.
We've been trying with the International Year of Quantum Mechanics, with the UN and all the efforts that they've been doing around this to participate to some of the events. I was there in February they hosted a conference in Paris for the launch of the Year of Quantum, and there was panels on quantum ethics, and there was a lot of concern about the geopolitics of quantum computing, with mostly the region in the north, in Europe and in Northern America, that have the technology, and how can we help other countries to either collaborate with these big hubs of research or help them kickstart their own research in quantum.
Or the Chinese government having it first, which
that's
is also an ethical
thing.
problem.
That's also the idea, but like.
And so that was the UN also?
That was the UNESCO.
UNESCO.
Yeah.
Being involved in the opening of the Year of the Quantum.
Mm-hmm. Yes, they did the opening ceremony in Paris, February 2nd and 3rd or something like that.
So UNESCO still have a program around quantum? Probably.
Oh yeah. They have a lot. They had a 2-day conference, and then they keep all year long. They're having programs.
All year long.
Mm-hmm.
Oh,
yeah. 2025 is the International Year of Quantum Science and Technology, and it's celebrating the 100-year anniversary of Heisenberg quantum mechanics.
There was also a conference about quantum and ethics at UCLA, but it always ends up to talk about AI because it's such a thing in this year. So it's like always end of it's like the shortest.
I think it's definitely linked. I think the ethical problem are slightly different for the two fields, but one of the big applications of quantum is going to bring more power, computation power to AI. So in a sense, the ethical problem that we can fix in AI will be like either helps by more computing power in the background, or make worse. And so I think maybe fixing ethical problem on AI will help us fix quantum ethics later on.
Or all the problems we have now with AI will be multiplied by the power of the quantum computers, which is like 1,000,000 times more or even more.
It's hard to tell because we can do back of the envelope calculation, but it depends on many things. And so it's easy to calculate the number of qubits that can like threefold, tenfold, millionfold give you more power. But I think what's important is logical qubits. And so it's hard to know how many qubits and how much power you will get if you don't have proper error correction.